How are you, my friends? This is Calculus 1, Solved Questions, Simple Curve, Sketching Part 2. Please, you can go and check Part 1 for more questions. Question number 1 here in this video, sketch the graph of f of x is equal to 3x to the power 5 minus 5x cubed. This is a polynomial function of degree 5. So first we check the end behavior. We can see here the degree n is odd, which is 5, and the leading coefficient is positive. So it's up to the right, down to the left on the behavior. Let's find the derivative f prime. You can see all this in lecture number 18 of Calculus 1. So f prime of x will be 15x to the power 4, as you know, power rule here, minus 15x squared. So we take 15x squared as a common factor. Then we have inside x squared minus 1, we can factor more. So we find the critical values. Critical values occur at f prime is equal to 0. So x can be 0 or minus 1 or 1. Now to find x-intercept, let y is equal to 0. So take the whole function is equal to 0, factor it. You find three values for x equals 0. X will be square root of 5 divided by square root of 3. And minus square root of 5 divided by square root of 3. Let's do on the next slide a table of signs to study f prime to see where is the increasing and decreasing for the function f. So we have seen f prime is 15x squared, x plus 1, x minus 1. So I put on the table here, table of signs, minus 1, 0, and 1. These are the critical values. Then I put x squared, it's all positive on the table, x plus 1, x minus 1. So I pick a number here as usual. We have seen this in the algebra course. Choose any number here like minus 5. You can put it there. It will be plus, minus, minus. And then between minus 1 and 0, I can choose minus half. Replace it in the x. From 0 to 1, I can choose half. From 1 to infinity, I can choose 5 or 7 or 8, whatever. So we can see here, f prime is positive. That means f is increasing. F prime is negative. So f is decreasing. Also here, there's a minus. So f is decreasing and then increasing because f prime is positive. So there is here a maximum, local maximum. Here is their local minimum. So if we put all the information together on the graph, we can see the local maximum here at minus 1. Replace minus 1 in the function, we get 2. And then local minimum at 1, replace 1 in the function, we will get minus 2. So f is decreasing on minus 1 to 1. It's all decreasing. Increases, f is increasing from minus infinity to minus 1, union 1 to infinity. And these are the x-intercept. Another functions, question number 2, sketch the graph of f of x is equal to 3 square root of x minus x square root of x. You can try that if you like, then you can see the slides after that. Now let's start here by the derivative. Find the first derivative. F prime of x will be the first term here is easy, 3 divided by 2 square root of x. And the second one here, we see x times square root of x, so we have to use a product rule for the second term. Product rule will be u prime v plus v prime u. See, we put all that in big bracket. There is a minus before that. So the derivative of x will be 1 square root of x. The derivative of square root of x, 1 over 2 square root of x times the x. Now simplify all that. You will get 3 minus 3x divided by 2 square root of x. Let's find the critical values. 1 f prime is equal to 0. So f prime is equal to 0. That means 3 minus 3x is equal to 0. The only critical value is x equals to 1. And also, we have to mention this is the graph of 3 square root of x minus x square root of x. So the domain will be only x greater than or equal to 0 from 0 closed to infinity. There is no value in the domain which is negative. So we have a local maximum at 1. and then we replace 1 in the function, so we get f of 1 is equal to 2. And also, this is a global maximum or absolute maximum, because this is the maximum value in the whole values of the range. F increases from 0 to 1 here, you can see that, and F is decreasing from 1 to infinity. So this is question number 3, where the graph of the function f of x is equal cosine squared of x minus 2 sine of x, x between 0 and 2 pi is decreasing. This is a simple question. This is from lecture number 18 in the calculus 1. So let's find the derivative f prime of x. The derivative of cosine squared of x will be 2 cosine of x times the derivative of the inside, which is cosine of x. The derivative will be minus sine of x. Here we have minus 2. The derivative of sine of x will be cosine of x. So I can take 2 cosine of x as a common factor. Inside, I will have sine of x minus 1. Critical values, they occur at f prime is equal to 0. So we can have here cosine of x is equal to 0. X will be pi over 2, which is 90. And minus sine of x minus 1 is equal to 0, which is sine of x is equal to minus 1. X will be 3 pi over 2, which is 270. Let's do simple table of signs to study the sign of f prime. So from 0 to 2 pi, we have the critical values, pi over 2, 3 pi over 2. From 0 to pi over 2, which is 90, I can pick any angle like 30 pi over 6, and I replace it in f prime here, cosine pi over 6, sine pi over 6. This will give me a negative value. So the function f is decreasing. I can choose from pi over 2 to 3 pi over 2 an angle pi. So it will be cosine pi. Here we have sine of pi. So all of this will be positive. So the function now f is increasing. From 3 pi over 2 to 2 pi, I can pick an angle like 11 pi over 6, which is 330. I replace it here, cosine 330, sine 330. It will be all negative. So the function is decreasing. So the question says where the function is decreasing from 0 to pi over 2 union 3 pi over 2 to 2 pi. Question number 4 says find the absolute maximum of this function f of x, x times e to the power minus x squared over 8 over the interval minus 1 to 4. So we have to study all the numbers from minus 1 to 4 and see where is the absolute maximum. We can start with the derivative f prime of x, and also we see here that we have a product rule. Product rule, u prime v plus v prime u. So the derivative of the x will be 1 here, times e to the power minus x squared over 8. The derivative of e to the power minus x squared over 8 will be minus 2x over 8 times the same function, times the x. Now I can take e to the power minus x squared over 8 as a common factor. Inside the bracket, I will have 1 from this one here, 1 minus 2 divided by 8 will be 1 over 4, and there is an x and there is another x, so it will be minus x squared over 4. Now the critical values, f prime is equal to 0. This exponential function cannot be 0. So we can have only 1 minus x squared over 4 is equal to 0. I take this on the other side, multiply by 4. So x squared will be 4. Take the square root of both sides, x will be plus or minus 2. Now be careful here. Minus 2 is not in the given interval between minus 1 to 4. 2 is there. So what do? I take the endpoints of the interval, minus 1 and 4, and 2 from the critical values. Minus 2 is not there, so I don't use it. So what do I have to do? Find the image, f of, this is the list here to check, f of minus 1. See, I take minus 1, replace it in the function. I take 2, replace it in the function. And I take 4 and replace it in the function. So I get f of minus 1, f of 4, f of 2. This is negative value. This is 4 over e squared, which is almost 0.54. And this is 2 times e to the power minus half, which is 2 over square root of E, which is approximately 1.2. So this is the highest. So this is the absolute maximum occurring at x equals 2. For more questions on simple curve sketching, you can see the lectures, please, number 10 and number 18. And for more questions on general in the Calculus 1, you can visit the playlist Calculus 1 Solved Questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.